everyone. We are Ajit Kumar, Alfia, Anushya, Amurthavarshini and myself Amrin from the Department of Artificial Intelligence and Data Science, Shriram Engineering College. Today, we are presenting a deep learning laboratory program on XOR problem using deep neural network. In this presentation, we will explain the XOR problem, the DNN architecture, forward and backward propagation, the code implementation, the output, and the final conclusion. This is XOR truth table. The output is 1 only when the two inputs are different. Otherwise, the output is 0. Since the XOR problem is not linearly separable, a single layer neural network can't solve it. Therefore, we use deep neural network with hidden layers. This is XOR truth table. The output is 1 only when the two inputs are different. Otherwise, the output is 0. Since the XOR problem is not linearly separable, a single layer neural network can't solve it. Therefore, we use deep neural network with hidden layers. During forward propagation, the input passes through the hidden layer and then the output layer to generate predictions. In back propagation, the predictions are compared with the expected output to calculate the error. The weights and biases are then updated using gradient descent to improve more model's accuracy. This slide shows the Python code used to train the model. The program performs forward propagation, calculates the error, computes the gradients, and updates the weight and biases. We train the model for 100 epoch with learning rate of 0.1. After training, the model learns about the correct weight and biases. The prediction matches the XOR truth table. The output for 0, 0 and 1, 1 are close to 0, while the output for 0, 1 and 1, 0 is close to 1. This confirms the program works correctly. The XOR problem can't be solved using single neural network. A deep neural network with a hidden layer successfully solves this problem using forward propagation, backward propagation, and gradient descent. This experiment demonstrates the basic working of deep neural networks. Thank you. We hope this video helps you understand how a deep neural network solves the XOR problem. Now I'll briefly explain the code implementation. First, we import the required libraries NumPy and Pandas. Then we define the XOR input values and their expected outputs. We set the number of training epochs to 100 and learning rate to 0.1. Next, we define the sigmoid activation function and derivatives, which are used during forward propagation and back propagation. After that, we initialize the weights and biases randomly for the hidden layer and output layer. During training, the model performs forward integration propagation to generate prediction, calculate the error, and then use back propagation with gradient descent to update the weight and biases. Finally, after training is completed, the program prints the learning weight and biases, showing that the network has successfully learned the XOR function.